Hi everyone, I'm back with another circuit question. And the question asks to Theveninize, meaning that find VTH and ZTH at terminals A, B of the circuit shown in figure 4. Why is it asking us to do that? Because we want to calculate Z load to be connected across the terminals A and B for maximum power dissipation of Z load. Okay, and then after that we can calculate what is the maximum possible power dissipation. Okay, so whenever it tells us to find VTH and ZTH at the terminal, if the terminals are disconnected or not, what we are going to do, we are going to disconnect them, even if they're not in the circuit, which they are here. Okay, so if we look at this, then we have VS here, and then these are open circuit, so it's like they're not even there. 6 ohm minus 5J, and then we have 2 ohm and then J10 here. Okay, and what we need to do here is VA, and here is VB. Okay, VA is basically 2 ohm multiplied by we can call it IA, meaning that we have a current going here is called IA, and then here we have IB. Okay, and then VB is going to be minus 5J multiplied by IB. Okay, now all we need to do is find IA and IB. IA is the voltage across these points, which is VS, over the full admittance impedance across VS, which is 2 ohm plus J10 ohm. Okay, this is IA, and then IB similarly is going to be VS over 6 minus 5J, and VTH is going to be VA minus VB, which is going to be 100 with 25 degree of phase over 2 plus J10 minus 100 with 25 over 6 minus 5J. And then we can do this math to find it. Okay, then in order to find, this is what we do to find VH. Okay, VTH, sorry. In order to find ZTH, what we will do, so to find ZTH, we need to short circuit ideal voltage source, or short circuit that, or open circuit ideal current source. Okay, so either this or that. Now if we short circuit the ideal voltage source, what would happen? We would have J10. Imagine we would short circuit this. Then J10 and 2 ohm, they would have a node that is common here, and then another node. These two nodes are common because of the short circuit. So it's as if J10 and then the 2 ohm are in parallel. Okay, and then what else do we have? The same thing to the 6 ohm happens, and then six ohm and then minus J5. And we have to look, you would say, why are these two in series? Because they only have the 6 ohm and the J10 only have one node in common. The other node is different. Okay, one of them, yes, the other node, which is common between these two, is connected, the other one is not. And then here we are looking at ZTH. So now we can say ZTH is 2 multiplied by J10 over 2 plus J10, because these two are in parallel. These two are parallel. And then we have 6 multiplied by 5J, 6 minus 5J, because these two are in parallel. And once we do that, once we do this math, then ZL is going to be ZTH conjugate. Okay, so yeah, we have to do this math basically for the phasors to find the solution. Once we find ZL, and we solve this problem, you can find this in different ways. By the way, you can say this is 20J over 20 plus J10 plus minus 30J over J minus 5J. One way you can get rid of the real and imaginary in the bottom is that, like, you can multiply this. You can multiply it by 2 minus J10. 2 minus J10. What would happen is that then you would have 40J here plus 200, because J multiplied by J is minus 1, and then you have another minus 1 here. And then the same thing here, 2 multiplied by 2 is to the power of 2 plus 10 to the power of 2. The same thing here. We can do this one by 6 plus 5J, 6 plus 5J. So you can say plus minus 30J, 6 plus 5J, and then here we have 6 over 2 plus 5 over 2. That way it becomes easier. You can actually do the math. This is 104, and then you can use a regular calculator basically after this point. Plus 150, and then 36 plus 25 basically. And then, yeah, once you do this, then you can basically say ZL for the maximum power dissipation or power delivered is ZTH conjugate. So conjugate, yes. And then the maximum power that we can do is you can say 4R TH, this is VTH to the power of 2, which we found VTH here. we found it here, and then you can just like replace it here. So that's it basically. It's a lot of phasors math, but you can do it, guys.